Hey, Anna. All right, I don't have the best setup right here, but I'm gonna try to, I felt like it was easier just to do a quick video here to help you with these logarithms. You're really not yet to the point where they want you to like put this in your calculator. So you really aren't using your calculator yet. We will get to that point eventually, but I looked at your work. It looks like you're on 7.3, and the ones that they're giving you are always gonna come out nice. And so don't worry about the calculator yet. In 7.4, that's when you'll start using your calculator, and there's a method that they'll kind of walk you through. But right now what we're doing is just kind of looking at some basic ones that we should just be able to do in our head. So the thing you have to remember here is that a logarithm is really just the power that you would want to put on this base number right here to end up with this number. So I did just some basic ones that are some different types that are commonly occur. So in this case, your base is a 2. So you're thinking 2 to some power would get me an 8. All right, well, that'd be a 2 cubed. 2 cubed is equal to 8. So what that means then is that this is equal to, let's see if I can write this. I've got kind of a mess going here. This would be equal to 3, because 3 would be the power you want to put on that base to get to an 8. Okay, now it's going to be nice if you know your perfect squares and your perfect cubes, probably up a ways, because if you don't know that 2 cubed is 8, then this is going to be a little bit more challenging. Maybe you want to make a list for yourself of what 2 cubed, 3 cubed, 4 cubed, 5 cubed, and it's probably high enough to get to that point. And then the perfect squares, you'd probably want to know at least up to 10. Okay, so assuming now that you know all your perfect squares and all your perfect cubes, you're hoping for something like this to happen, where this is a perfect power of your base. And in 7.3, everything they give you will be. So some weird ones that can happen. This one right here. If you're going to take 2 to some power and end up with a fraction, all right, if you'll recall that if you have a negative exponent, that will bump your value to the denominator. So in this scenario, I want to take 2 to a negative power, so it'll bump that 2 to the denominator. So something like this would equal -1. All right, the other one, and so I could change this, but if it's a negative power, that's what's going to turn it into the fraction. Sorry, my dog was going crazy there. He needed to be released. Okay. All right, here's our next one. The other thing that'll happen is this square root, or it could be a cube root or a fourth root. It could be any root. But what we have to remember on this is that if you want to end up with a square root, that's really just a 1/2 power. If you had a cube root, it's a 1/3 power. So in something like this, they're saying 2 to what power is a square root of 2? Well, that'd be a 1/2 power. And so your logarithm is always equal to what power you want to have. And then the last main type here is anytime you take the log of 1. This one's kind of special because I could do log base 3, log base 7, log base pi. I saw they had one like that in there. It doesn't matter what the base is. The only way you can get to a 1 is if you raise something to the 0 power. So anytime you see the log of 1, regardless of that base, it's always going to be a 0. So 2 to the 0 power is 1. Sometimes we kind of do this loop, and this is kind of futuristically, but we sort of say 2 to some power is equal to this 1. And we kind of do this loop thing. That's how you're doing that. Okay, there's one other scenario I thought of after I did this that I should have written on here as well. And that would be just a very generic concept of if you take the log, and I don't care what the base is, I'm just going to call it base B, of some number over here, and I'm going to write it as a B to some power. Ultimately, this is your goal every time. You're trying to figure out, I'm kind of changing this value that's over here on the right side. Like I would change this 8 so that it is the same base as the base I'm shooting for. If you can do that, if you could rewrite that so that it looks like this, then you know that your answer would always be X. So for example, I don't really want to mess this up too much. I want to kind of be able to refer back to this. But this is the idea, is that you're going to take this log base 2, and instead of writing an 8, you're going to write it as a 2 cubed, because 8 is 2 cubed. And see how I've managed to get the base and this value to be the same? And so if you can get it to be written like that, then your logarithm will just be that exponent that's sitting there. Now, sometimes we can just do it in our head. I was just doing these in my head, just knowing that 2 cubed would get me an 8. But sometimes as they get fancier, maybe this would be a method that could help you. If you rewrite this number, this is actually called the argument, that if you rewrite the argument so that it looks like it has the same base that you're shooting for over here, then that exponent will be your answer. Okay, so now I'm going to throw some examples at you. All right, so in this one, you have to get, it's a base 3. 3 to some power would be equal to a 9. Now that would be one I'd like to think you could do in your head. 3 to some power is a 9. All right, so ideally you just know that 3 squared is 9. But the alternative to that would be to go ahead and change this 9 so that it is a number, same value, but has a base of 3. So you would change your 9 to a 3 squared. So it would look like this, log base 3 of 3 squared. And then once you have those the same, you know your answer is that power. So either one of those options is okay. All right, let's get a little fancier. Let's go over here to this one. Okay, notice I turned it into a fraction. Negative exponents are how you turn things into a fraction. But up here I gave you a very basic one because this base was the same as this number here. So it was just a -1. Now I'm changing it up. I'm making it a little harder. So I'm still going to have a negative exponent, but it won't be a -1 because it's not a 4 here. It's a 16. So what power do you raise a 4 to get to a 16? Right. Well, you'd be a 4 squared would turn into a 16, but since it's in the denominator, it'd be a -2 instead of a +2. That's not a z, that's an equal sign. It kind of drug, sorry. So it equals -2. If you were doing this other method, you would change this 1/16 and you would say, well, that's a 4 to the -2 power. It's squared, but it's also bumped to the denominator. And so then right here, that exponent is your answer. But I sometimes feel like if you can do this, then don't you really already know what your answer is at that stage? So could we just write the answer? Okay, let's try again. On this one, I have a 5 that I'm going to have to square to turn it into a 25. So I know I'm doing a 5 squared. But I also have this cube root. That's a little bit tricky because the root was a fractional power. If it's a square root, it's a 1/2 power. If I have a cube root, it'd be a 1/3 power. That's what I'm going to want. I'm going to want a 1/3 power. So what this is going to turn into is a log base 5 of, now here I go. I have two things happening. I have to square it and I have to take it to the 1/3 power. So it's going to look like this. 5 squared to the 1/3 power. And then what we do is we clean this up. A power raised to a power, these should get multiplied. So a 2 times a 1/3 is really a 2/3. I didn't give myself much room here. So this I would clean up to a 5 to the 2/3 power. And then there again, once you write it with the same base, then this exponent is your answer. So in the end, this equals 2/3. All right, and I'm just doing